Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4. This is lecture number 4 of a unit system of particles, and rotational motion. So let's begin with today's class. In today's class we are discussing it's an introduction to a rotational motion, and then we will switch to the inertia of a rotational motion. So let's begin that what is rotational motion? What do you think? What is rotational motion? Let's directly see certain examples and you might get an idea that what we can say is that let's suppose this is one of the planet that is moving around the sun. This is the rotational motion of the earth. This is the rotation of a top. So what we can observe is that all this are the motions that is around the fixed axis. And when you need to move around any of the fixed axis, you require a rigid body. Then and only then this is possible. So now the new question arises that what rigid body is. So let's first look what rigid body is all about. We can say that for a rigid body, let's suppose this is the body, or when I can define this as a rigid body. So we can say that for the rigid body, the size and shape of the object remains constant. You can see this that force or certain force is acting on from the every direction on this object. But even though a force is acting on the system, there should not be any change in the size and shape of an object. If it is the case, then this body can be considered as a rigid body. So it says that under the application of an external force, the distance between any two particles does not change. And if distance between any two particles does not change, that means the size and shape of this rigid body would be the same. If it is the case, we can call it as a rigid body. I hope this is clear. Is it clear? So what is rotational motion? We can say those it is the motion around the fixed axis. But to move around any fixed axis, what you need to do is you need a rigid body. And what rigid body is? It is the body which does not change its dimensions. While I say dimensions, I mean its a size and shape, even though a large amount of force is acting on the body. So if this is the case, we can say that the object is rigid body. I hope this is clear. Is it clear? Is it? Are you sure? Great. So now, first, what rotational motion is about? What is rotational motion? Rotational motion, the motion along a straight line path? No. What does it call? The motion along a straight line path? Yes, it's a translatory motion. This is what we call as a translatory motion, not the rotational motion. The motion along the curved path? No. The motion along a rectangular path? No. It's a motion along a fixed axis. Yes, this would be the correct option. I hope this is clear. Is it clear? Great. Next, when the body sorry, when the body is in rotational motion, the particles of the body executes linear motion? No. Circular motion? Yes, definitely. Both? No. None of the above, not possible. I hope this is clear. Yes, so all the objects are moving in circular motion. Let's have a look that the situation could be something like this. Let's suppose this is sphere kind of thing, and this is the rotational axis around which it is rotating with speed omega. So if you observe this particle, then this is moving on the circular path, something like this. If you observe this particle, then this is again moving in this path. Yes, so every particle is moving in the circular motion. Does it clear? Great. Next, the motion of the giant wheel is an example of it is the case of rotational motion, because it is something like this. Here its central would be there, and it is moving in this, yes, about any fixed axis. So this is the rotational motion. Did you get this? Are you sure? Are you sure? Great. So now to understand the rotational motion well, we need to understand the one very important aspect of the rotational motion, and that is moment of inertia. So let's just understand the what moment of inertia is and what is physical significance. What is physical significance of moment of inertia? So let's begin with the moment of inertia. Please have a look to this very carefully, because we are on the second session. We are on the second part of the system of particles and rotational motion. Ideally, it has been divided into two segments. One of the segment was center of mass and their motion, and now it's a second segment of the session. It's a rotational motion. So please have a look at this very carefully. So let's begin about with the center moment of inertia. Sorry, what moment of inertia is. Let's suppose, look at this. This is, I could say, this is one of the rigid body. Yes, and it is moving, or it is trying to move with this rotational axis in the, I can say, in the clockwise direction. Arrow is indicating for the same. So when we see that when a rigid body rotates about an axis, there is always a tendency to oppose any change in its state. Let's suppose initially this was at rest, and by somehow we are trying to rotate it. There is always a tendency to oppose any change in this state, and this property to change, this property of the body, that can be measured by a physical quantity that we call as a moment of inertia. This tendency to oppose any change is what we call as a moment of inertia. If you remember the laws of motion or motion in straight line, we have defined inertia first time over there. Yes, that we could say that inertia, it is just the tendency to oppose any change. But at that point of time there were only three inertias. That one was the inertia of motion, another is the inertia of rest, and another is the inertia of direction. Yes, because we were discussing the translatory motion, that object is moving, then it will keep it moving. If object is at rest, then it will wish to, or it will try to keep it at rest. If object is moving in certain particular direction, it is not going to, or it will not like to change its direction. This was the inertia. Now we are talking about the rotational inertia, that we call as a moment of inertia. So if object is at rest, it would not like to start rotating. Or even the reverse is true, that if object is at moving, if object is rotating with certain angular velocity, let's say omega, then it will not like to stop. So this is what we call as a moment of inertia. I hope this is clear. Yes, so moment of inertia represents inertia of body in rotational motion. We can say it's a reluctance to change in its rotations. So we call this as a rotational inertia as well. And the role played by the moment of inertia in rotational motion is same as the role played by mass in translated motion, that is we have discussed. Yes, so whatever the thing that are played by the mass in the translatory motion, it is the same here, it is going to be played by the moment of inertia. Let's look at the factors on which moment of inertia of rigid body depends. So it depends on the following factors. First, it depends on the mass of the body. Second, it depends on the position of axis of rotation. And the third, it depends the manner in which the mass is distributed around the axis. So this three parameters, this is going to be dependent on the three parameters. I hope this is clear. Yes, it depends on the mass, it depends on the position of axis of rotation, and it depends on the manner in which the mass is distributed around the axis. So how could I find out the moment of inertia for a point mass? Let's look at this, that this is a point mass having mass m, and this is my rotational axis, and this mass m is at perpendicular distance from the rotational axis. That perpendicular distance has been represented by r. So So what I could say is the moment of inertia of the point mass is equals to m into r square, where m is the mass of a particle, or we can say mass of an object. It is mass of an object, while is the perpendicular r is the perpendicular distance from the axis of rotation. So it is the perpendicular distance from the axis of rotation. Got this? So moment of inertia I can be calculated as m into r square. I hope this is clear. Yes, it is just the multiplication of mass multiplied by square of the perpendicular distance. Does it clear? Does it? Great. Now, if I want the moment of inertia of a discrete system, what I'm supposed to do is, if I consider it is that there are many masses having mass m1, m2, m3 up to mn, and this is my rotational axis. Uh, Let me show you. Yes, this is my rotational axis around which all these particles are rotating with, let's say, certain speed omega. So m1 is at distance of r1, m2 is at distance of r2, m3 is the distance at r3, such as mn is at distance of rn. So the total moment of inertia of the system would be equals to I is equals to m1 r1 square plus m2 r2 square plus m3 r3 square up to mn rn square. And while I write this, I am simply doing this thing. It's an I is equals to sigma I equals to 1 to n miri square. So it is just the addition. It is just the addition of m into x square. I hope this is clear. Any doubts? Any doubts? Yes. While I write the moment of inertia, while I write the moment of inertia I, it's a moment of inertia. Does it scalar or vector? We can say it's a scalar quantity. It is a scalar quantity. Its unit it's a m into distance square, so it's a kg into meter square. Dimensional formula, it's a kg to the power 1, so it's an m1 meter to the power 2 l2. No dependence on time, it's a m1 l2 t0. So these are the basic information, but we must know this. So I is the moment of inertia. I hope this is clear. Is it? Is it clear? Great. While doing m into r square, please keep in mind this r is not the radius. I don't know why. Generally, you made a mistake that r is the radius. No, r is not the radius. It is not at all. Yes, so r is the perpendicular distance from the axis of rotation. Please keep this in mind. And let's look at this question. It says that the reluctance to undergo a change in the state of the body in rotational motion is given by moment of inertia. Yes, great. Next, moment of inertia depends on the mass. Yes, it is. It depend on the position of axis? Yes, it is. Does it depend on the manner in which the mass is distributed? Yes, it is. So it depends on all of the above. This should be the answer. Got this? Next, for a discrete system, mi is given as, yes, so it was the situation like this. Let's suppose this is the rotational axis. This is the m1, this is the perpendicular distance r1. This was the, let's say, m2, this is the perpendicular distance r2. Same way, this is the mn and this is the perpendicular distance rn. So this moment of inertia could be written as, it would be an m1 r1 square plus m2 r2 square plus m3 r3 square up to mn rn square. So this is equals to I is equals to sigma I is equals to 1 to n mi ri square. This is the correct option. So I is equals to sigma I is equals to 1 to n mi ri square. I hope this is clear. Is it clear? So all theoretical aspects do this are clear. Are you sure? Are you sure? So will you be ready for the questions? Yes. So have a pen and paper with you guys. Do it with me and let's do it quickly. Let's have a look. So the situation is something like this. This is the rotational axis. This is the one of the object having mass of 2 kg. This is the distance, which is a 4 meter. Here this is the different object having a mass of 3 kg, and this distance is 2 meter, and they are rotating like this with this as a rotational axis. So what they want that find out moment of inertia. From next time onwards I will write it as an mi. Do not understand this is mission impossible. No, this is not mission impossible, this is moment of inertia. Yes. So find out moment of inertia of the given diagram. Yes. So let's do it quickly. How will you do this? What I understand is I is equals to m1 x1 square. Please write down x1. Yes, because I'm not sure that you are not going to use r as a radius. Yes, I'm pretty sure you are going to do this. Yes, so please write down the x. There are less chances to get an error. So it's an m1 x1 square plus m2 x2 square. The mass one, it's a 2 kg multiplied by 4 is the distance, so it's a 4 square. Plus mass 2, it's a 3 kg multiplied by 2 as a distance, it's a 2 square. So this is equals to 2 into 4 square, it's a 16, plus 3 into 2 square, it's a 4. So this is equals to 32 plus 12. This is 32 plus 12, it's a 44 kg into meter square. I hope this is clear. Was it? Was it clear? Was it? Are you sure? Can you do this? Can you? Great. Let's look at the next question. Suppose the situation is something like this, that this is triangle. I could say it's an equilateral triangle, and masses, or we can say point masses, have been placed over the vertices. All these are the three same masses. The dimensions of this triangle is 2l by 2l by 2l. Yes, every side's having a dimensions of 2l. So what I need to say is that find out mi of the given diagram. Find out moment of inertia of the given diagram. So first, this is the rotational axis, and with respect of this is the first, I should say 1 1 dash. So first it's a I 1 1 dash, moment of inertia across rotational axis 1 1 dash. You need to find out this. How will you do this? So what I understand is let's understood this very carefully, that this is the situation something like this, that this is the rotational axis, and on this rotational axis this mass is there. So what I understood is when point mass is on the rotational axis, when point mass is on the rotational axis, then moment of inertia of that mass is always zero. Why? Why? Because in this case x is equals to 0, perpendicular distance. When we say this is point mass, so ideally this should not have any dimensions. So moment of inertia, let's say it that this is first mass, this is second mass, this is third mass. Yes, moment of inertia due to first mass would be equals to m into x square. It's a 0 square would be 0. I hope this is clear. Is it clear? Is it? Now, moment of inertia due to first mass is 0, that is for sure, but there would be a moment of inertia for the second mass, there would be a moment of inertia for the third mass. So how could I write this? So what I can do is that moment of inertia due to second mass, that would be equals to would you like to see the diagram again? This was the situation. This was the 1 1 dash, and the separations were 12. Equilateral triangle has been set. Yes, this all are the MMM. Yes. So let's write it down. Moment of inertia due to second mass. It would be that would be m into 2l whole square. That is equals to m into 4l square. Even moment of inertia first mass. Moment of inertia due to this third mass. Sorry, this was considered as a first. This was considered as a second, and this was considered as a third. So this is this their separation, and when I write their separation is this, when I write this separation is this, that was the L. I hope this is clear. So I3, it's an m into L square. This is m into L square. So moment of inertia I across 1 1 dash, it is equals to I1 plus I2 plus I3. Yes, I1 is 0. Why? Perpendicular distance was 0. Plus I2, plus I2, it's a 4 ml square plus ml square, and that would be equals to 5 ml square. Got this? Got this? Great. So we will continue with this question. Now the situation would be something like this. These are the m. Now you are going to rotate this from here to dash. Yes. So the question is, find out mi from 2 to dash. Moment of inertia of the system from 2 to dash. This is the rotational axis. Yes, this was just the extension of previous question. So when I say extension, the dimensions would be the same. It's a 2l comma 2l comma 2l. So what I need to do is, this is was considered as a first, this was considered as a second, this was considered as a third. Now in this case you can observe that I3 would be 0. Why? Because it is on the rotational axis. When it is on the rotational axis, x would be equals to 0. Now what is moment of inertia due to first? Do it quickly. You are doing great job. Well done. So this is midpoint. This is L. I1, I could write it's an ml square. What about I2? Again that would be equals to ml square. So what about the I22 dash? It is this plus this plus this. So it would be a 2 ml square. I hope you got this. Have you? Have you? Are you sure? Can you do this? Great. Shall I add something? Let's have a look. This is the rotational axis. Let me call as a 3 3 dash, from 2 2 dash and 3 3 dash. So let's work for this. What will you do? What will you do? So when I work for the I3 3 dash, what I understand is I1 equals to 0. Why? Because rotational axis passing through it, it's an x equals to 0. I2 would be equals to 0. Why? Because rotational axis is passing over it. But I2 definitely would not be a 0. So what I need to do is that I need to find out this y as a distance, because it is the perpendicular distance of the second, or sorry, of the third mass from the rotational axis. So this is L, this is y, this was 2L. So what I can do is, for me it's an I3 would be equals to m into y square, and to find out y, what I can have is the L square plus y square is equals to 4L square. So this y square is equals to 4L square minus L square, it's a 3L square. Keep this as a y square because you are requiring y square itself. So this is equals to m into 3L square. So I33 dash would be equals to this, to 0 plus 0 does not have any difference. This is m or I should say it's a 3 ml square. This is I33 dash. I hope this is clear. Is it clear? So will you capable enough to do this? Are you sure? Can I have one more question? Will you do this by yourself? Are you sure? Let's do it quickly. Now the question says that let's suppose a square is there and it is having masses on its vertices. Again, these are the particle masses or these are the point masses. This is m, this is m, this is m, this is m, and the dimensions of the square is 12 by 12. Yes. So this is find moment of inertia from where? Let's have a look. Yes, let's do this. This is my 1 1 dash and I require this. So let's do the thing that we will give them a number. This is 1 2 3 4. Yes. So to find out I11 dash, what I need to do is that this is required. Now moment of inertia due to first mass would be a 0. Moment of inertia due to second mass would be a 0. Why? Because x, it's a perpendicular distance is 0, because they are on the same rotational axis through which the system is going to be rotated. Now what about the I3 and I4? So I3 would be there, definitely it would be there, and this perpendicular distance is the 2l. So this is equals to m into 2l whole square. It's a 4ml square. Same way for the I4, it's a m into 2l whole square. This would be is equals to 4ml square. Yes. So the I11 dash would be equals to 4ml square plus 4ml square plus 0 plus 0. So this is equals to 8ml square. This is the moment of inertia across 1 1 dash. Now, now let's suppose you want a moment of inertia of the system if system is going to be rotated in this. Please keep this clear. This is 2, this is 2 dash. Now I required I22 dash, what it would be. I hope this is clear. Yes. Does it? Does it clear? Yes. So for I22 dash, what I understand is that moment of inertia due to 3 and moment of inertia due to 2 would be 0. Why? Because perpendicular distance is 0. Now for I4, for moment of inertia due to fourth mass, that would be equals to m into 2l whole square. If you think for the first mass, even it would be the same. So it would be a 4ml square for the I4 as well as for the I1. So this is I22 dash would be equals to 4ml square plus 4ml square, and that would be equals to 8ml square. I hope this is clear. Is it? Is it clear? Are you serious? Are you serious? Can you do this? Can you? Is it possible? Are you sure? Great. Well done. Let's work for the next question based on this only. Yes, in the previous question, what I need to do is that this is the square of four masses were there, and they have been given label as first, second, third, fourth. So this four labels have been used: first, second, third, and fourth. And when they have been used, the dimensions, that means the lengths were 2l comma 2l. We have find it out: 1 1 dash, 2 2 dash. Now, let's suppose I need to find out. I need to rotate this with this. It is, yes, from this. this rotational axis. Let me give this name as a 3 3 dash. So you need to find out this I 3 3 dash. How will you do this? What I understood is that I1 is 0, I3 is 0. So moment of inertia due to first mass is 0, y on the rotational axis, x is equals to 0. Moment of inertia due to third mass is 0, y again perpendicular distance is 0. You need to find out moment of inertia due to 2 and moment of inertia due to 4. So what it would be, what the distance would be. So what I can do is that let's find out this distance. This is 2L, this is 2L. So let's call this complete as a y. So this y square would be is equals to 4L square, 2L square plus 2L square according to the Pythagoras. It's a 4L square plus 4L square, it's an 8L square. So this y should be is equals to, y would be equals to under root of 8, which we can say it's a 4 into 2, which is 2 root 2L. But you are going to rotate it from here. So this is what we can say is the R1. It is the half of the y, or if I say this is the R2, again this is the half of the y. So I can say R1 or R2, which is equals to y by 2, which could be written as 2 root 2 divided by 2, which will be a root 2. Got this? Are you? Great. So let's just find it out the remaining parts, remaining masses, because 2 is going to be rotated, fourth is going to be rotated, and when this 2 are going to be rotated, this I2 could be written as I2 could be written as it's an m into r2 square. It's a perpendicular distance from the rotational axis. So this is equals to m into r2 square, which is equals to 2. So this is equals to root of 2l, I mean. So this is 2l square, this is 2ml square. I hope this is clear. Is it clear? Now what about the I3? I3 is 0. What about the I4? So I4 would be equals to m into r1 square. This is equals to m into r1. This is 2l square. That could be written as 2ml square. So this I total, or I should say it's an I33 dash, I33 dash, that could be written as I33 dash. What it would be? It is due to this 2 0, and due to this 2 it's a 4ml square. I hope this is clear. Is it clear? Is it? Are you sure? So when you write a moment of inertia and you have a different values of moment of inertia, let's have a look quickly that if you have rotated this triangle from this, the I33 dash was the 3ml square, or let's suppose ki if we are talking about this square plate, yes, or we can say a square where point masses are there that has been attached at the vertices. So if I write I11 dash or I22 dash, yes, that was the 8ml square. So what I understand from this is, and we must understand that this is I11 dash, this is I22 dash, they require, or they are having an inertia of 8ml square, and I33 dash, this is having an inertia, of 4ml square. So from this you can understand that this configuration this configuration is easy to rotate if I take a path of 33 dash, rather to rotate it from I11 dash or I22 dash, from here or from here. I hope this is clear. Do you understand this, the meaning of this? Do you? That it is easy to rotate from I mean say I33 dash. Yes. I hope this is clear. Is it clear? Is it? Are you sure? Are you? So let's just keep this continue. This was the situation. M M M M. This was 12. Even this was 12. Now what you are supposed to do is that you are going to rotate this. You are going to rotate this from here, and it is something like this. So cross represents, it is perpendicular to the plane of an object. It's a perpendicular to the plane of an object. Let's call it phi dash. So what it would be? So what I understand is that if you look at this very carefully, no masses have been passed through the rotational axis. So every object is going to rotate, as well as let's assume that this is the distance. We can call it as an x. So every object I1 or I2 or I3 or I4, this all object having a moment of inertia as an m into x square, because all are at the same distance. So now what is x? What is x? We have recently call it as an r1, or we can call it as an r2. That was the root 2l. So in this case this is m into x square, which is equals to 2l square. So the I dash would be equals to 4 into m into 2l square, and that would be again equals to 2 4s are 8 ml square. So again, it was it was difficult as compared to this rotational axis that passes through the diagonal only. Yes, so this moment of inertia would be the 8 into ml square. I hope this is clear. Is it clear? Is it? Like to have one more thing? Would you like to have one more thing? Are you sure? Are you? Yes, let's have a look. Do you find this interesting? Do you find this interesting? Let's have a work for this. That this was the situation. This is m, and this is 12. Yes, let's suppose you are going to rotate this from here. It is the midpoint. This could be called as a 6 dash. So for I 6 dash, this separation is L. This separation is L. Yes, same thing is true for this m into L, m into L. So it's an I1 equals to I2 is equals to I3 is equals to I4. This is equals to m into L square. So this I6 dash is equals to ml square, ml square, ml square, ml square. Yes, so this is equals to 4 ml square. That's it. You did it. Well done. Great job. Does it clear? Does it? Are you sure? Are you? Great. Let's work one more. Yes, it is passing through the midpoint. Yes, and this is what I call as a 7 dash. So you need to find out the I7 dash. Again the thing will be the same. Again the thing will be the same when you are going to rotate this like this. Let's suppose in this case you are going to rotate like this. So their way of rotation would be the changes. Way of rotation would be the changes. In this situation, it is moving in the vertical plane. Yes, while in this situation it is moving in the horizontal plane. Yes, or we can say across the horizontal plane or across the vertical plane. But what it would be, what I7 dash should be, it is the same thing, that this would be the L, this would be the L, and so on. So if these are the cases, I7 dash is again I7 dash would be equals to 4 ml square. I hope this is clear. Is it? Is it clear? Is it? Great. I would like to have one more. Let's have a look. This was the situation. M, 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 M. This is 12, 12. Yes, this was the case. Now what you need to do is that this is the axis across which you need to rotate it. This is the axis you need to rotate it. Now you understand easily that what does it mean. It's an 8 8 dash. Let's just do it. How will you do it? So let's again give the number, because at this situation the this mass is passing, or rotational axis has been passing through this mass. So when I calculate I88 dash, I understand that moment of inertia due to fourth mass will be a 0. Why? Because again perpendicular distance is equals to 0. Moment of inertia due to first, it's an m into this separation. Perpendicular separation is 2l. Look at this. This is perpendicular. That means you must assume that have a sketch of this in your book, and just point out the we can say the nib of your pen, or the pointer of your pen, into the plane of the paper, so that your pen or your pencil should be perpendicular to the square, and the nib of that point should be on the M. And now you are going to see the perpendicular distance from this pen. So this will be the I1. It's an M into 2L whole square. That should be is equals to 4 ml square. For I3 again, that perpendicular distance is m into 2l whole square. That would be equals to 4 ml square. But for I2, for this object, this would be the perpendicular distance. Let me show you. This would be the perpendicular distance. This is 2l, this is 2l, so this is 2 root 2l. So for I2, I should write it as this is m into 2 root 2l whole square. This is 2 2s are 4 2s are 8. It's an 2 2s are 4, 4 2s are 8. Yes, it's an 8 ml square. So this moment of inertia 8 8 dash, this moment of inertia 8 8 dash is equals to 4 ml square plus 4 ml square plus 8 ml square. This is equals to 4 plus 4 8, 8 plus 8, it's a 16 ml square. I hope this is clear and you get this clearly. What was your answer? What was it? Was it same? Was it? Are you sure? Are you sure? Great. So let's just wind it up this session over here. I am winding up this session over here because what I want that you just have a grip on the moment of inertia of the point masses first, and when we will be back with the next lecture, we are dealing with the moment of inertia of rigid bodies. So please have a grip over this, and then only we can switch over to that. Please do questions, as as many questions as possible. Thank you. Have a good day. Take care. Bye bye.